In order for the induction motor to operate, it is necessary to split the phase. This is done by taking the live and the neutral connection and connecting it onto the stator windings in a way so that we've got two separate branches running. This will in turn generate two coils, and because these coils have different inductances and different resistances, they will cause a different lagging effect on the current and in essence the magnetic field. We will have a starting coil as well as a running coil. When considering the starting and the running coil, let us accept that the current flow, instantaneous current through the coil, which will be directly proportional to the size of the magnetic field that is created, is generated by the formula sine theta. And let's say this is for my starting coil. Alright, so at 0 degrees we know sine theta at 0 degrees is 0. If we look at 30 degrees, sine theta will be 0.5. If we look at sine 60 degrees, we know that it's going to be approximately 0.8. I'm rounding down. And then at 90 degrees, we've got 1. Okay. For the running coil, we're going to have this exact same situation. However, we're going to accept that the current flow that's generated for the running coil has a 30-degree delay. Alright, so we're going to look at sine theta minus 30 degrees for this scenario. So there we're going to have minus 0.5, there we're going to have 0, there we're going to have plus 0.5, and there we're going to have 0.8. Again, I am rounding down. Now let's accept that in our motor my starting coil is placed on the horizontal axis and the running coil is placed on the vertical. So my starting coil is placed like that, and my running coil is placed, so that's brown, my running coil is placed like that. Okay. So we see that the starting coil has no magnetic field at the initial start. So we've got 0 flux lines on both sides. And let's take these values we calculated and we just multiplied by 10. And we say that the running coil has generated 5 flux lines. So we've got 5 flux lines, and let's say north is that side and south is this side. We've got 1, 2, 3, 4, 5 flux lines there, 2, 3, 4, 5 flux lines over there, and because there's no additional flux lines, we see that we've got a north over on that side and a south over on that side. When our supply rotates in 30 degrees, the two coils will split those phases and we will have our starting coil at 0 flux lines, and we will have our running coil at 5 flux lines. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, let's say that's the north and that's the south side, that means that our flux lines generated will be 1, 2, 3, 4, 5 with north on this side and south on that side. So we can already see that there's been a rotation on the magnetic field in the stator. If we do a third set, right now we're going to have 8 flux lines on my starting coil. That's still the north side, that's at 0 degrees, that's at 30 degrees, this makes it at 60 degrees. At south I've got 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8 flux lines there. My running coil is going to have 5 flux lines, 1, 2, 3, 4, 5. There needs to be a south, which means that's going to be a north, 1, 2, 3, 4, 5. And we know that flux lines takes the easiest route. So we're going to have 1, 2, 3, 4, 5, 1, 2, 3 remaining over there, and then 1, 2, 3, 4, 5. So we can see that our north has moved into this general direction and our south has moved into that general direction, giving us an overall flux field in typically that direction. When we go on to 90 degrees, that's my north, that's my south, and I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 flux lines. On this side we've got still a south, but now it's gone up to 1, 2, 3, 4, 5, 6, 7, 8 flux lines, and there we still have a north, 1, 2, 3, 4, 5, 6, 7, 8 flux lines over there. And when we look at this configuration, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8. We can see that this flux, field of flux, has now moved more in its direction, and as a result we can see that there is a constantly rotating magnetic field. Now the operation of the induction motor, these flux lines as they rotate will magnetize and allow conduction in the rods in the rotor. Those rods will generate their own magnetic fields, and those magnetic fields in turn will react with these magnetic fields, which has an overall effect of generating a rotating force on the rotor.